All right, folks, so here's the second video on fingerprint features. Our first video talked about some of the fingerprint features, including fingerprint ridges and how they're formed. It talked about pattern area. It talked a little bit about ridge flow, and then we gave a short list of the different fingerprints, arches, loops, and whorls. This particular video is going to focus on something called sufficient recurve. Or recurving ridges. If you remember in the last video when we talked about fingerprint flow, we said that some fingerprints, the ridges flow in from one side, they rise up in the middle, they flow out the other side in the case of an arch. Or in some cases you might have fingerprint ridges which form a circle or circuit pattern in the middle, which is what happens when you have a whorl. Or, like we have here in this fingerprint, some ridges have a tendency to flow in from one side, recurve or do a sort of U-turn or loop, and recurve out the same side. And so we have what are called these recurving ridges. Now, if you remember from our last video, about 60 to 65% of fingerprints are loops. In order to be able to classify a fingerprint as a loop, it must meet three qualifications, three specific variables. It must have at least one good or sufficient recurve. So it must have at least one good recurving ridge. It must have what we call a delta, which we're going to talk about in the next video. And then it also must have what's called a ridge count. But this video is going to talk about that first one, which is having a sufficient recurve. When we look at this fingerprint here, we can see that there are several ridges. In fact, there may be as many as 8 to 10, 1, 2, 3, 4, 5, 6, 7, 8 or so, that flow in from the right-hand side. We can see that they rise up, and then they do a sort of U-turn, and then they flow back out that right-hand side. So we have about 6, 7, maybe even 8 ridges that actually recurve. Some fingerprints, other types of loops, might have 15 or 20 recurving ridges. You might even have some fingerprints, though, that only have just one recurving ridge. In order for any fingerprint to be classified as a loop, though, it must have at least one good or sufficient recurve. So let's talk about what that means. All right, so a sufficient recurve consists of a space between the shoulders of a looping ridge that is free of any appendages which abut upon it at a right angle on the outside of the recurve. The shoulders of a loop are the points at which the recurving ridge definitely turns inward or curves. So if we're looking at a recurving ridge in a fingerprint, the shoulders are the points on that recurving ridge where it turns inward. So we can see on this fingerprint ridge here, here's the shoulder on the left and here's the shoulder on the right. On this fingerprint, we can see the shoulders here and here, here and here. Now, why do we need to identify the shoulders? Well, the reason for that is if there's an appendage that is sticking to the outside of a recurving ridge, somewhere between the two shoulders, then that actually spoils that recurve. It's no longer a sufficient or good recurve, and so we would have to look at another recurving ridge as a good one in order to be able to classify the fingerprint as a loop. An appendage is any sort of an attachment or connection to the ridge. And again, an appendage that strikes the outside of the recurve at a right angle spoils that recurve. So looking at these fingerprints here, what we need to do in order to be able to classify each of these fingerprints as a loop is we need to have at least one good recurving ridge. So let's look at the fingerprint here on the right. The ones we want to look at first are the innermost recurving ridges. And the reason for that is later on we're going to talk about what constitutes a fingerprint's core. And the fingerprint core is going to be found either on or within the innermost good recurve. And so we need to find the innermost good recurve. So looking at the fingerprint here on the right, although we can see that there are 8 or 9 or 10 recurving ridges, we're interested in the most innermost good one. So let's find the innermost recurving ridge. In fact, we can see that the innermost recurving ridge is this one here. Now the question is this a good or unspoiled, or what would be referred to as a sufficient recurve? So if we look at it here, we can see that it flows in from the right-hand side, it recurves around, and it flows back out. Now the question is, does it have any sort of appendages that are on the recurve that would spoil it? So we're going to find the two shoulders. So here's one of our shoulders. And then here's the other shoulder, and there doesn't seem to be any sort of appendage, which would be like a point or a spike on the outside of the recurve that would spoil it. And so this innermost recurve is actually a good one. Now, if this one was spoiled, all we would do then would be just to move to the next outermost recurve. So we'd go to this next one. Now this one actually is spoiled because notice how it doesn't connect. That's okay though, because this innermost one is actually good. So we can see that on this particular fingerprint, it has certainly at least one, in fact more than one good recurve. But let's look at the fingerprint here on the left. Again, a recurve is a ridge that flows in from one side, it does this U-turn, and it flows back out the other side. Now when we look at this fingerprint, most of the ridges actually don't recurve. So for example, this ridge flows in from the right, it goes across the top and then flows back out the left side. Whereas so do all the rest of these other ridges. There's really only just the one ridge, this one here, that flows in from the right, it recurves around and flows back out that same side. Now, in order for this fingerprint to be classified as a loop, remember one of the qualifications is it must have at least one good recurve. So we only have one recurve here, so it's got to be a good one. In order for it to be an unspoiled, good, or sufficient recurve, remember it can't have any sort of appendages on it. And the good thing is we can see that this ridge, it flows around, and there's no appendage on there, so it does have at least one good or sufficient recurve, which is one of the reasons why this fingerprint here on the left is in fact a loop, because it does meet at least that first qualification of having one good sufficient recurve. Alright, so let's kind of practice a little bit on figuring out whether or not the recurves we find are good or they're spoiled. Because you're going to do an exercise in our Canvas course on looking at some different recurves and determining whether they're spoiled or good or not. So here's some examples of spoiled and good recurves. So for example, let's look at number 1. We can see, and by the way, it's labeled as spoiled, so the S you see here means it's spoiled. When you see a G, that means we have a good recurve. So looking at number 1, we can see that this one is obviously spoiled because between the two shoulders, here's a shoulder and here's a shoulder, we have this appendage that comes off at this 90-degree angle. So this one is spoiled. So in our fingerprint, if this was the only recurving ridge, well, this ridge is spoiled. And so if this is the only recurving ridge, then we couldn't have a loop. So if we went back one slide, so imagine that this ridge here, this is a good one, but imagine this had an appendage on here. If this had an appendage on here, then this ridge would be spoiled, and so we would no longer call this a loop. So if this is the only recurving ridge, this appendage here would spoil it, so it would not be any good. We can see that this recurve is spoiled, again, because of an appendage. Here's another spoiled one because of this appendage. We can see also number 4 is spoiled. Number 5 is spoiled. Number 6 is spoiled. Now, number 7, notice that we have a ridge on the inside here, but notice that it doesn't penetrate and it doesn't spike outside of the recurve. So this is actually still good. So too is number 8. This is a good recurve. Now here's an interesting thing. Look at number 9. Here we actually have two different recurving ridges that overlap slightly. Again, we're interested in the innermost recurving ridge. So if we look at this innermost one, we notice that it is, as it begins to loop around, that the other ridge actually kind of acts as an appendage. It actually spikes outside of it. So this one's actually spoiled. But if we look at this ridge, we notice that between the shoulders, this shoulder and this shoulder, there's no appendage, so actually this one's good. So we have at least one good recurving ridge here with number 9. The same thing happens here with number 10. This recurve is spoiled, but this recurve is actually still good. All right, so you can see number 16, 17 is spoiled, 18 we have a good one, 19 we have a good one, 20 we have a good one. Number 16 is actually a good one because this is not an appendage. This is actually a dot that sits just above the recurve. So this is still good. That's not actually an appendage. It's a dot that sits above. So we can see, we can actually look at recurves to figure out if they're good or spoiled if we have what's called a sufficient recurve. Now, a rule about sufficient recurve. Now, what if we do have a spoiled recurve? What do we do now? Well, when we have a recurve that's spoiled, so if the innermost recurve is spoiled, then we go to the next recurve outside of it. If it's free of any appendage, then it's going to be a good one. And so we can see here in our examples, number 1, the innermost recurve is spoiled, so all we do then is just go to the next outer one. So we go to the next outer one, we see that one's good. All right. Number 2, again, same thing. The innermost recurve is spoiled, so we just go to the next outer one, and this next outer one is good. Now, what if this one had been spoiled? Then we just go to the next outer one. So why are we interested in figuring out which recurves are spoiled and which ones are good? Well, the reason for that is that's going to help us later on to figure out where the fingerprint's core is located. And to figure out the fingerprint's core, we're going to talk about that in a later video, but the fingerprint core is either going to be found on the innermost recurve itself or inside of that innermost recurve. So we need to figure out what the best, sufficient, or good innermost recurve is, because that's going to be where we're going to place our core. And so we need to figure out which ones are spoiled and which ones are good. All right, so that concludes this next video, which talked about sufficient recurve. Now that you've watched this video, you can go ahead and log back into the Canvas course and go ahead and complete the sufficient recurve exercise that's there.